Hello class, so in this video we're going to be talking about the Fundamental Theorem of Calculus. So there are two parts to it, and I normally don't call them part 1 and part 2 like a lot of textbooks do, because a lot of textbooks call them by different things, like part 1 and part 2 will be switched in different places. I think usually this one is considered part 1 and this is considered part 2, but I just don't use them because there's too much interchanging. So I'm just going to call them by what they actually do. So the first one I'm going to go over is called the net change part. Then the other one is the derivatives part. So as long as f is continuous and then big F is an antiderivative of small f, then this will hold true. And then for the derivatives part, essentially if you take the derivative of the antiderivative, then you get the function itself. So let's just look through how this works, and then yeah. So I want to give us some geometric intuition into why the net change part works, and then use that to get the derivatives part. Okay, so just knowing what an integral is, we know that this is going to represent area, right? Area under f on this interval. So let's look at big F of b. So that's going to look like this. That's representing that area, right? And then what about big F of A? It's going to represent that area. So what if we were to take big F of B and big F of A, and then just take big F of A away? So in other words, let's just look at exactly what we have. First we have this. This is the integral from 0 to b of f of t dt. In other words, big F of b. And then here we have the integral from 0 to a of f of t dt, which is big F of a. Let's take that away, and we get this, right? So that's just the stuff left over there. So in other words, the integral from a to b of f of t dt equals, you take, so the area between is, you take the big area, take away the small area, and then you got that. That's what is left. This is why the net change part works. So now let's look at this, the derivatives part. So we have integral from somewhere a to x, or k to x, or whatever it is. Usually you'll see it as a to x. So I'm just going to write it like that here, even though I know I wrote k up there, but same idea, dummy variable. Okay, so if we take the derivative with respect to x, then what we get is this. The derivative of the integral from a to x of f of t dt equals f prime of x. And because of the fact that f prime, so big F is the antiderivative of small f, right? So by definition, that should work because of this whole idea. So let's use that and talk about how this works. So here's some practice. So here you're going to need to have the antiderivative of each of these parts. So let's just rewrite this so that we can more easily take the antiderivatives. In other words, as powers if needed. 1 over x, you don't need to turn that into a power because the antiderivative is just ln, right? Okay, so it's going to be ln of the absolute value of x minus x to the 3 over 2 over 3 over 2 plus e to the x from 1 to 10. All right. So let's do that all out. I'll do it over here. So ln of 10 minus 2/3 10 to the 3 over 2 power plus e to the 3 over 2 minus ln of 1 minus 2/3 times, so that's just 1, plus e to the 1. Alright, so this reduces to, well, that's nice, that goes away. Ln of 10 minus, so this is the same thing as saying 10 square root of 10, so I'll just do it that way. and then plus e to the 3 over 2 plus 2/3 minus e. Yeah, there's not really much of a way to make this look nice, so I'm just going to leave it like this. Looks a little bit crazy, but notice that all we really did was just found individual parts that are antiderivatives of these, evaluated at each of the limits, and then got this. Okay, let's find the derivative of this thing then. So essentially this is your f of t value, right? So let's just look at big F actually. So if we were to do this, then we have big F of x squared minus big F of square root of x. So in other words, that would give us f prime of x squared times actually 2x, because chain rule, right? Minus that times 1 over 2 square root of x. Okay, so what is f prime? So that's just f of t, right? So f of small f of x squared times 2x minus small f of square root of x times 1 over 2 square root of x. Alright, so we have 2x times then sine of e to the, okay, so that t is going to become an x, so e to the x squared squared is x to the 4th minus 1 over 2 square root of x times sine of e to the, oh, that's nice, that's just x, because square root of x squared is just x. Okay, so one thing I wanted to highlight with this was the fact that what you're really doing is applying the chain rule to a derivative here. So make sure that if the limits of integration here are not just x, that you do apply the chain rule to each of the parts that need it. And it's helpful to just write it out like this if necessary. Then you can kind of visualize exactly what's happening. Alright, so that's the end of this video. Hopefully that was helpful, and I will see you in the next video.